Hey, this is Math 7, Unit 3, Lesson 4, Applying Circumference. We've been talking about circumference last couple times, and circumference is going to be that distance around a circular object. And so we're going to be using pi today to help us solve problems to figure out what circumference is. Pi, if you recall from previous lessons, could be something like 3.14 as an approximate value, or you can use a fraction 22 over 7, and those are the common ones you're probably going to want to use for the lesson today. Alright, so here are some pictures of circular objects with measurement tools shown. Alright, the measurement tool in each picture reads as follows. The wagon wheel is 3 feet, and so that we have a tape measure that goes from edge to edge, and it says 3 feet there. It says the plane propeller is 24 inches, and we have a measurement tool there for 24 inches. And then we have this tape measure that goes around the slice of orange for 20 centimeters here. I can drop that here, 3 feet there. For each picture, which measurement is shown? And so for the wheel, that is showing us the diameter, because we're going from one edge to the center to the other edge there. For the propeller, we're talking about from the center to one edge there, that would be the radius. And then for the orange slice, because we're going around the object there, that would be the circumference. Based on this information, what measurement could you use or could you estimate for each picture? Alright, so for the wheel, because I have the diameter, I could find out what their circumference could be. No problem there. I could estimate that, no problem. Easy to do. For the propeller, because I have the distance of the radius, I could also figure out the circumference there. In terms of the orange slice, because I'm given the circumference, I could figure out what the radius might be or what the diameter might be. Okay? We could also tell, in this case here, I could also technically tell what the radius would be half of that, or in this one here, the diameter, which would be half of that as well. But that's not really what they're asking for this time. That's okay. Let's take a look at the next page. We're going to be using pi in this next section, and what I'd recommend here, at least for my kiddos here, is we're going to use our approximation of pi. We're going to use 3.14 just to stay nice and consistent throughout this activity here. So we're going to complete the table here using 3.14 as our approximation of pi. Alright, so we know that to get from diameter to circumference, we're going to do pi times the diameter is going to be equal to our circumference from our previous lesson there. No problem. We also know that the radius is going to be 2 times, if I multiply times 2, I get the diameter. If I want to go this way though, that's going to be the reciprocal, which will be a half. Alright? So let's start here. The wagon wheel. Because I'm going this way, I'm going to use a half of 3, which is 1.5. To find the circumference though, I'm going to use the diameter and multiply by 3.14, and we end up with 9.42. Okay, and that's going to be still feet. Okay, radius. Radius, if I multiply by 2, will give me the diameter, which will be 48 feet. If I multiply that by my approximation of pi, 3.14, I end up with my circumference, which is 150.72. Now moving this direction here, I'm going to have to divide by pi. Okay, and 20 divided by 3.14 is about 6.36 for the diameter. Okay, we're going to be dividing by pi to go this way. Here we multiply by pi, now I'm going to divide by pi. And to go this way again, it's going to be times a half. And so half of 6.36 is 3.18. So that's how that table is going to work out there. Again, using the value of pi to multiply or divide, and recognizing these are difference of either times multiplying by 2 or multiplying by a half, the reciprocal there. Using this information, we look at number 2, which is a good question. This kind of question is going to come up quite a bit in this unit, okay? It says a bug was sitting on top of the propeller blade when the propeller started to rotate. So imagine here's your circle, the path the propeller is going to go around, and a propeller is sitting right there, and here's the length of the propeller blade, there it is, and there's a bug up here sitting right there. There's our little buggy. Okay? And it says the bug held on for 5 rotations. It's going to go around 5 times before flying away. How far did the bug travel before it flew off? So what we're saying is that this bug is going to be going around the circumference of this shape, pi d, and it's going to do that 5 times. So whatever the circumference is, pi d times 5, is how far this bug is going to travel. So looking at the propeller blade from up above, we knew that the diameter was 48, so we can plug that value in there. Pi was 3.14 times our diameter, which is 48, times 5 rotations. It's important to keep this in mind. Again, this comes up quite a bit in this, this unit this time, okay? So 3.14 times 48 times 5 is going to give you 753.6, and in this case, we're measuring the whole thing with inches. So the bug, staying on the propeller 5 times, goes around 1, 2, 3, 4, 5, for a total of 753.6 inches. What a trip the bug had. All right, looking at the next question. The next question is about a track and running around the track. It's a great question, and one that I've actually done in real life in making a track for a team to run on in the grass. Lots of fun. So it says a field inside a running track is made up of a rectangle that is 84.39 meters long and 73 meters wide, together with a half circle at each end. So you have a rectangle there and a half circle here and here. It wants to know, first of all, what is the distance around the inside of the track, and explain or show your reasoning. The distance around the inside of the track. So first of all, the distance from here to here is a straight line. No problem. That's going to be 84.39. We're going to do it one time here and one time there. So we can add that up, and we know that the straightaways, as we call them there, is going to be equal to 168.78 meters. That's that part there. That's our straightaways. But for the curves, this part and this part, they're going to combine together to form a circle, aren't they? So to find the circle is going to be the circumference formula. The circumference is pi times the diameter. In this case here, because we're doing the inside of the track, my diameter happens to be 73. So I do 3.14 times 73. I'm going to get a value of about 229.22. Okay? Now when I combine those two together, this value and that value together, so the straightaway plus the two curves, okay, and the two curves is really just one circumference because one whole circle, and I end up with 398 meters is my distance around the inside part of that track. Okay, that's what I have. Now I'm going to use that same information to answer number 2. It says the track is 9.76 meters wide all the way around. So I have this extra space all the way around the track, 9.76. What is the distance around the outside of the track? Explain and show your reasoning. So we said before, if I started right here on the inside, it's 398 meters around. But if I start on the outside, I'm traveling a little bit further. If you ever watch a track race, you notice that people start at different points along the track, depending on what lane they're in. And it looks like they have a head start, but they really are going to be running the same distance because it's further on the outside than it is on the inside. So to figure that out, here's what we have to take a look at. First of all, the distance from here to here is not any different from there to there. It's still a straight distance there. So I know that the straightaway part is still going to be 168.78. That's not going to change. What will change though is going to be the circle part, right? The two half circles together. Before, my diameter, my pi times d for circumference, was 73. But now my diameter has to change. It's going to be the 73, but I'm also adding to it 9.76 here. And I'm also going to be adding a 9.76 here. So I'm adding that value 2 times for a longer diameter. Okay, so I have to add those things up. So 73 and 9.76. Let's do my calculator here. Let's clear that out. So 73 plus 9.76 plus 9.76 is going to be 92.52. I'll take that value now and I'll multiply it by pi, that's my new diameter, to find out the new circumference. And that value is going to be 290.51, I can leave it there, 51, however you want to do it, 5128, whatever you want to do. Okay, now when I combine these together, 168 and 290, I end up with 459.29. Okay, and that becomes my distance around the outside of the track, which is very interesting to compare, because if I ran the inside of the track, I go 398 meters. If I go on the outside, I go 459 meters. That's a lot further, isn't it? And this is going to be about 62 meters further on the outside, which is why this person gets to start further up ahead, or so it would appear in a race. Okay, let's take a look at the next one. We're going to go now. I'm going to skip this part here, but it's a good question to figure out if you wanted to. Talking about how close to the inside of the track someone had to run in order to run 400 meters in one lap. Because as we saw before, if you're right on the edge, you're running a little less than 400. So how much off the edge would you have to be in order to actually get 400 is what that question is asking you to do there. But let's take a look at 4.4, measuring a picture frame. It says Kieran bent some wire around a rectangle to make a picture frame. The rectangle is 8 inches by 10 inches. We want to find the perimeter of the wire picture frame, so that we're going to find out what all this is going to be in terms of perimeter. What we have is a whole bunch of circumferences, don't we, going around that there. So let's take a look at, first of all, the wire frame. These little half circles. If this distance is 8, what I see here is I have 1, and I have 2, and I have 3, and this one here, this is together makes a 4. I have 4 diameters basically going across here. So that would tell me that the length of this is going to be a 2, and a 2, and a 2. This becomes a 1 and a 1. So it tells me that when I look at one of these circles here, the diameter for one of the circles around is going to be 2. That's my diameter. That's the same over here too. Take a look. If I have 1, 2, 2, 2, 2, and 1, I have 2, 4, 6, 8, 9, 10, and that gives me my same value, 10, just like I had my 8 there. Okay, so I know my circle has a diameter of 2. My diameter equals 2 for these little circles around the outside of the picture frame. The question though is, how many picture circles do I have? Okay, so I could have this one here, let's call this A. So there's A, here's B, here is C, put this one D for that one, here's E, here's F goes there, and here's G. So already I have 1, 2, 3, 4, 5, 6, 7. So I have 7 half circles, which means I have 14 half circles. I have 7 full circles there. Then I have these guys, they're 3/4, right? Well, a 3/4 and a 3/4 is going to be 1.5. So this plus this is 1.5 circles, and I do it again down here for another 1.5. So that becomes 1 plus 1 is 2, and a half makes 3. So that means I have 3 of those. I have a total of 10 circles. So it took a little bit of kind of thinking about that to say, all right, I have 10 circles altogether around this here, each the diameter of 2 inches. Okay, so to find the perimeter of the wire frame is going to be, right, the pi times the diameter, okay, and I do that times 10 times. So we would have 3.14 times the diameter, which is 2, times 10, because I have 10 of them, which is going to give me 62.8 inches. Okay, so it's pi times d circumference times 10 of them to find out the distance around that frame is 62.8. If the wire frame picture were stretched out to make one complete circle, so if I took this and unbent it and made one giant circle, okay, we already know that the circumference is 62.8, right? What would the radius be is our question. Well, to find out the radius, think about what we know. Circumference equals pi times the diameter, or circumference equals 2 times pi times the radius. Okay, depending on how you want to think about that there. Either one could work. So let's take a look here. If my circumference is 62.8, okay, and I set that equal to 2 times pi times r, I can do a couple things. I can divide everything by 3.14. Okay, and when I do 62.8 divided by 3.14, I end up with 20. Okay, so we could say that 20 equals 2r. And now if I divide both sides by 2, I end up with 10. And so my radius would be 10. And that's how I would get that one there. So using my equation, I just work kind of backwards there to figure out what that could be. Alright, so that's how we solve that one. Let's take a look at your summary then for today. In terms of summary, we have a couple things we're talking about. We know that the circumference of a circle is pi times the diameter, and we know the diameter is twice the radius. So if we know any one of these measurements for a particular circle, we can find the others. So these become the things that we know. The diameter equals 2 times the radius. The circumference can be pi times the diameter, or 2 times the radius times the pi. And that's what we're looking at today. We're going to go on to our homework now, so if you want to press pause and do your homework and then check it out, that'd be a great idea. So here we go. Alright, so here's a picture of a Ferris wheel. It has a diameter of 80 meters. Okay, on the picture, draw and label diameter. So we can go from here, straight across to here, and we can call that 80 meters, and there is our diameter. How far does a rider travel in one complete rotation around the Ferris wheel? That's going to be asking about the rotation, which is going to be the circumference, and circumference equals pi times the diameter. Pi is 3.14, our diameter is 80, and 3.14 times 80 is 251.4 meters is how far it's going to go. Again, that's an approximate. Technically, it's going to go a little further because you can see the basket is a little bit away from the actual ring there. But that's okay. We're just getting close here. All right, number 2. We have lots of little equations to solve here for number 2. It says identify each measurement as the diameter, radius, circumference of the object, then estimate the other 2 measures for the circle. All right, so what do they give me here? The length of the minute hand on the clock is 5 inches. We're going to call that a radius. So the radius is 5 because that's the part of the clock that goes from here to there, which would make our diameter double that, which is going to be 5 times 2 is 10. And the circumference is 10 times pi, which is going to be, right, we have pi times 10, which equals 31.4. Okay. The distance across a sink drain is 3.8 centimeters. We're going to call that a diameter of 3.8. So our radius will be half of that. So half of 3.8 is going to be 1.9. And then our circumference is going to be pi times 3.8, which is going to equal 11.932. Alright, the tires on a mining truck are 14 feet tall. So tires are this tall, 14 feet. Again, that's all the way across. We would call that a diameter, or 14. The radius is going to be half of that. Half of 14 is 7. And again, circumference is going to be pi times 14, which is going to equal, in this case here, wrong number there. We're going to do 3.14 times 14, and we have 43.96. There we go. The fits around a circular pool, so we're going around a pool, is 75. That to me is a circumference. 75, we're going around an object, 75. So then to solve for the diameter is going to be the 75 divided by pi, divided by 3.14, which is 23.8. The radius then is going to be half of that, which will be 11.9. Okay? So diameter is circumference divided by pi. That's how we solve that one there. The distance from a tip of a slice of pizza to the crust is 7 inches. So we're talking about, here's a slice of pizza, from here to there is 7. So we call out the radius as 7, which makes the diameter 14, which makes the circumference 14 times pi, which we've had before, and that's still going to be 43.96. We had that same one on C, didn't we? Okay. Breaking a cookie in half creates a straight side of 10 centimeters long. So here's our cookie. We break it in half, and we have a straight side of 10. That would be our diameter. That's 10. The radius would be half of that, which is 5. And the circumference is 10 times 3.14, which is the same as A, which is 31.4. And G, the length of a metal rim around the glass, circumference is 190 millimeters. So our diameter is going to be 190 divided by pi, which is in our case going to be 60.5. Our radius is going to be half of that, so our radius would be 30.25. And finally, the edge, the center to the edge of a DVD, so here to the edge, is 60. So we would call it the radius is 60 millimeters, which makes the diameter double that, 120, and the circumference is going to be 120 times pi, or 376.8. Okay? Now again, in all mine, I'm just giving the answers there. You're probably going to need to show your work. Make sure your teacher knows that you know how to do that as well. And they didn't just watch the handy dandy video. Okay, let's move on to number 3. It says in number 3, great question, and you'll have things like this coming up on your assessment as well. So here we go. It says a half circle is joined to an equilateral triangle with side lengths of 12 units. So this is 12, that's 12, and this is 12 as well. What is the perimeter of the resulting shape? Okay, well I know that this length is 12 and 12, so I know I'm already starting with a 24 in terms of what I have for these values there, 24. But I need to find out the length of this semicircle there. This is not a full circle, but I can figure out what the value is going to be. The circumference is going to be pi times the diameter. We know the diameter is 12. So you have 3.14 times 12. Okay, we're okay with that part, no problem. 3.14 times 12 is going to be equal to 37.68. Now, that would normally be where we stop, except now we're only going to be using half of that circle. So I take that value, 37.68, and I multiply it by a half. And 37.68 times a half, or divided by 2, same thing, comes out to be 18.84. So now what I need to do is take my value of 18.84 and combine it with a 24. And when I combine those together, what I end up with is 42.84 is the distance around the entire shape. So this is my 18.84 and 12 and 12. Number 4, it says circle A has a diameter of 1 foot, circle B has a circumference of 1 meter, which circle is bigger? And then we have a little value there to show what's going on. Well, what I need to do is either compare the diameters or compare the circumferences. It doesn't matter as long as I'm comparing the same thing, but I also want to give them the same units as well. So what I want to do first for me, I'm going to compare some diameters here, okay? So let's take a look here. Actually, we'll see. This diameter of 1 foot, if I draw that out, and that was 1 foot. 1 foot is the same as 12 inches, and 1 inch is 2.54. So if I take 12 inches and I multiply 2.54, I end up with a diameter here of 30.48. centimeters. Okay, is that one right there. That's the diameter right there. Now, my other one, I said my other circle had a circumference all the way around of 1 meter. Now, circumference equals pi times the diameter. So I know if that's 1 meter, okay, 1 meter, and then this is going to be equal to 3.14 times the diameter. If I divide this by 3.14, then what I end up with is 0.31 is equal to the diameter. Now that's meters, so I want to turn it into centimeters. So in terms of centimeters, we would say this is going to be about 31 centimeters. Okay, so my diameter here is 31, my diameter here is 30. This one has the greater diameter, so we would say that the second shape, circle B, is larger than circle A because it has a greater diameter. Not by much, but by about half a centimeter. Okay, it's a little bit interesting question there to think about. Several different steps, a little bit more complicated, but you want to end up comparing diameter to diameter when you're all said and done to figure that out. But you have to do some conversions and stuff to convert inches to centimeters, and then also be able to turn your meters into centimeters again and figure that out as well. So a little bit complicated, any more than what you might be ready for number 4. Next one, number 5. The circumference of Tyler's bike tire is 72 inches. So circumference, in this case, is 72 inches. So here's a tire and going around 72. What is the diameter? Well, let's set that up. We're going to do this. We'll say circumference equals pi times the diameter. All right. So if we divide both sides by pi, 3.14. 72 divided by 3.14 is 22.92. And that's what my diameter is going to be. If I ask you for the radius, could you do that? Sure. Cut that in half and you have a radius. That's it for now. Hope that helps you out with your homework. Great job, and we'll see you next time.